This is question number 5 of DSE 2021 paper. Let's see what the question is saying. Suppose that n participants have distinct name arrived for a conference. The organizers have prepared name tags for all of them, but by mistake allocate name tags randomly to the participant. Now here you have to assume that this allocation is taking place simultaneously. What is the expected number of participants who will receive their own name tags? So please understand this. There are n participants, okay? And each of them, if they get their own name tag, there is there is only one correct name tag for them, and the remaining n-1 name tags are incorrect for them, right? So each has a probability of n-1 factorial upon n factorial, which is nothing but 1 by n actually, chance of selecting their own name card. This is the correct probability, isn't it? So if there are, supposedly I tell you that there are 5 participants, let's say that there are A, B, C, D, and E, 5 participants, and I have 5 name tags also. These are the name tags. There is only one correct name tag for a participant. Now, when these participants are randomly given these name tags, it may be possible that B may get A, B may get C, B may get D, B may get E. So B may get the remaining 4 name tags. That is also possible. All of these are incorrect name tags. And B may get his own name tag, which is the correct name tag. So out of the 5 name tags, there is only one correct name tag for B. And the remaining 4 are incorrect name tags. So the probability of getting a correct name tag is 1 by n. Same goes for each person. They may get a correct name tag or they may get an incorrect name tag because it is going simultaneously. Now, there is only one such situation where all will get correct name tag. When A gets A, B gets B, C gets C, D gets E, and E gets E. This is the only correct option. Other than that, everything is incorrect. So, other than everyone, there is only one possibility that all of them gets the correct name tag. Otherwise, other than that, there is no other possibility. So, only one such possibility when everyone gets the correct name tag. Now it says, what is the expected number of participants who will receive their own name tag? So I have to, I have to go ahead and check what is the expected number of participants. Now let's go ahead and let's check that out. So to check that, what we can go ahead and we can do is the following. We can say that there are n people. Each of them gets a correct name tag with the probability of 1 by n. And because I have to find expected value, I will sum this, and the sum of this will nothing be, but it will be 1. So what is expected value? Expected value is nothing, but it is, it's nothing, but it is probability multiplied by the number. So it's like this. Actually, this itself is the sum, but it is like this. The first person gets the correct name tag with the probability of 1 by n. Then the second person also gets the correct name tag with the probability of 1 by n. The third person also gets the correct name tag with the probability of 1 by n. And the last person also gets the correct name tag with the probability of 1 by n. So this is nothing but n into 1 by n when I sum this over, which is nothing but 1. So basically the expected value, that is only 1. So this is the solution. The solution is that there is only, the expectation is 1, that each one of the person will get a correct name tag. This is actually an example of linearity of the Bernoulli theorem, right? So there are different ways in which people go ahead and prove this question. Few of them, what they will do is the following. They will say, let there be a random variable, Bernoulli random variable x. And for each individual I, this x takes 2 values. It takes the value 0 or it takes the value 1. So there are two values which x can take. Either it can take 0 or it can take the value 1. It takes the value 0 if, let's say, the person is getting wrong tag. And it takes the value 1 if the person is getting correct tag. So if the person gets wrong tag, then xi is 0. If the person is getting correct tag, then xi is 1. These are the two possibilities. Now I have to find expected value of xi. So expected value of xi will be xi into probability that xi is equal to a certain x summed up, and x can take only two values, 0 or 1. So this will be 0 into probability that xi is 0 plus 1 into probability that xi is 1. So this will be nothing but it will be 0. Probability that xi is 0 will be what? It will be all the other possibilities. You get a wrong tag all the remaining number of times, so n minus 1 by n, plus you get the right name tag only one time, so this is 1 by n. So this will be 1 into 1 by n, which will be 1 by n. Now this is the expected value of xi, right? Now xi was only for one individual I. How many such individuals are there? N individuals. So what I will do is expected value of xi, which means x1 plus x2 till xn, will be 1 by n plus 1 by n and so on till 1 by n, which will be n by n, which will be 1. So the answer to this question is 1. So this is also a way of solving where you formulate a Bernoulli and you go ahead and you mark the answer. So the answer is 1.